So welcome back to my next webinar on Modern Java by Example. What we're going to do today is continue our exploration of WebFlux. And in this particular case, we're going to modify another example we've looked at before and have it so that we're going to have a publisher publishing in one process and then sending the data as a flux to a subscriber running in a different process. And this will give us a chance to understand how Project Reactor works in conjunction with WebFlux in order to be able to send reactive objects like fluxes and monos across the network. So let me go ahead and show you what we're going to talk about, and then we'll get ourselves underway. So let me first start by sharing my screen. And this, of course, is where the material will be today. We're going to be looking under Reactor and EX4. So this is the part of the code we're going to look at. And now let's go ahead and actually look at the code itself. Okay, so let me do that. All right. So this particular program is going to apply WebFlux and Project Reactor features to implement various types of back pressure strategies. And it's going to have the publisher running in a microservice in one process, and it'll be producing a flux stream of random integers, and then the subscriber will be running in one or more threads in a different process, and it will go ahead and consume this stream of integers. And there's some other stuff that we've talked about before, like memoizers and so on, but we're not going to cover that today. You can go back and watch the previous videos. So let me kind of start off by showing you where the interesting code is. Here's the publisher folder, and you can see we have a publisher application, which is basically a Spring Boot application. And when this starts to run, and I'll actually just start it up now just for kicks. So let's go ahead and run this application. That will go ahead and start up. Hopefully all will go well. All is going well, so it's up and running. And what this is going to be doing is it's going to have a controller down here that defines a bunch of methods. So we've got one method that's going to be used to basically create the publisher or initialize the publisher. And what that's going to do is that's going to make a new publisher object with the count and the max value that are passed over from the subscriber side. And it's going to go ahead and make that publisher. We'll look at that code in a second. And then it returns an empty mono because we don't really need a result. So that's one of the things you can do. You can start up a publisher. And this doesn't actually start it publishing. It just goes ahead and initializes it. In fact, while we're here, let's just go take a quick look at what initializing a publisher means. So what it means is we're going to go ahead and make ourselves a new list of random integers between count and max value, which were provided by the client. And we go ahead and store that. So this particular set of values will be usable by the different ways in which we run the subscriber. We'll see a couple different variants of that. Okay, so that's one thing you can do. That's one web call you can make to kind of initialize things. And you can see that that basically just gets directed to the publisher /_create endpoint, and that's this method. Then down here, this is really the interesting one. This is the StartPublishing method. And this is going to be called, of course, by the subscriber when it wants the publisher to start emitting those random values. And what you can see we're going to return here, and this is really cool, we're returning a flux stream of integers. And so what this is going to do is this is going to sit over in its own address space, in its own process running in the publisher app, and it's going to be generating a stream of random integers, which is going to be passed back to the subscriber as a flux. So this is really cool. Here's what we do. We pass in the back pressure enabled Boolean, which is passed over from the client, and that's going to select the type of emission strategy we use. So first thing we do is we're going to give ourselves a new scheduler. So this is going to run in the background on the server, on the publisher microservice. And then we're going to go ahead and create the appropriate back pressure, or make the appropriate emitter. And it's either going to be a back pressure emitter or a non-back pressure emitter. And then we're going to go ahead and subscribe this on the publisher. So again, this is running in the background in a microservice process. And this code is identical to what we had before. We are either going to send back chunks of data based on the back pressure information or we're just going to blast it all back out in one fell swoop. And so those are sort of the two strategies that we're doing here. I'm not going to walk through that code other than to say what's going to come back will be this stream of this Flux stream of randomly generated integers. So that's the publisher side. And notice that's its own web service. And then the last piece of the puzzle here is going to be the stop publishing method. And what this does is this goes ahead and tells the publisher to shut yourself down. You take a look at what that does. It tells the scheduler to dispose of itself. So it disposes of the scheduler and returns an empty mono. You'll notice that just for kicks, I made that a delete operation, an HTTP delete request, because we're kind of stopping the scheduler. I made the start publishing via get mapping because we're requesting something. And I made the create publisher be a post mapping because we're creating something. I probably don't need to do 3 different things. I probably could have used get for all 3 of them, but I'm trying to stay within the boundaries of the semantics of get, post, and delete. So if I've got that wrong, I'm sure someone will correct me, but I think that's pretty close. Okay, so that's the publisher side. And I think you'll agree the bulk of this code is just good old Project Reactor code. There's nothing in the publisher that looks really anything like it's doing anything across the network. The only place where there's any network-related stuff is in the controller, and all the controller's doing is really serving as an adapter between the underlying middleware, which is Spring-based, and the application code that we're writing here using Project Reactor and Fluxes and so on. And Fluxes are what's being used to send the data back to the subscriber, as you'll see in a second. Okay, so now let's push back over here to the main program. This is the driver. And you'll see that I've refactored a bunch of it in some interesting ways, although some parts are very similar. So as before, we have a publisher scheduler and a subscriber scheduler. We have a hybrid back pressure subscriber, which uses that push-pull back pressure model when that's enabled. We have a publisher proxy. We'll look at the publisher proxy. Publisher proxy is really cool. And that's what we're going to be using to make requests from the subscriber application over to the publisher application, using, of course, the web service calls that are baked into Spring and WebFlux. When the program starts, we run everything. A lot of this looks identical to what we had before. We start up the schedulers. We either run them in the same scheduler, the publisher and subscriber. Keep in mind, this is now the publisher proxy because we're on the subscriber process. That either runs in its own scheduler, or we make a scheduler and then we can control the number of threads that are running in the scheduler that are running the subscribers. We'll look at that in a second too. And now we have something new. This was not in the original version because, of course, we weren't using microservices back then. But I go ahead and make an instance of publisher proxy. So let's go take a look at publisher proxy. Publisher proxy is just a little helper class that's the proxy for the subscriber to make web calls on the publisher microservice. So this is how it's going to basically initialize it, start it publishing, and stop it when it's no longer wants to receive the data. Now to do this, we go ahead and create a couple of URIs. We have one that's used to create, one that's used to start, and one that's used to stop. You'll see how that gets used in a second. We make ourselves an instance of a web client, which is how you basically connect to microservices server using a host name. In this case, we're using localhost with port 8080. Here's the constructor for publisher proxy. You can see that it goes ahead and will put in the base URL where we're going to find the server, and it builds that little publisher, and you'll see why we need this because we're going to reuse it for other calls. And then the very first thing that we do in the constructor is we go ahead and send a post request, and the post request is going to include the number of items we want the publisher microservice to generate, and also it defines the range of values we want to be generated randomly. So these are things we get out of our instance singleton, and those go into the URI that we're creating. That's part of the query string that we're making. Then we go ahead and basically retrieve the response. So we do the connection, send the request over, get back the response, and we convert that to a void mono, because we're not really expecting to get a value back, but we need to get something back, so we get a void mono. And we're just going to block until that's done. So when this constructor returns, we have now got ourselves connected to the microservice, and we've indicated how big we want the data to be and what properties of the data we want. Another operation to look at shortly is StartPublishing. So StartPublishing is given a scheduler, and we're going to go ahead and send a GET request to the microservice, the publisher microservice, and we're going to give it the StartPublishing URI, which has the _start portion of it. And then we're going to say whether or not we want back pressure enabled, yes or no. So that's the query parameter operation. And then we go ahead and send that request over. And what comes back here is very interesting. What we get back here is a flux, which is basically a stream of integers. And of course, those integers are going to be sent to us by the microservice. And so we're going to sit there and basically consume them because we are the subscriber. And this is really cool. And then we go ahead and subscribe this publisher proxy to run on the given scheduler. So we're going to have one thread that's going to sit there basically pulling the data from the, or it's going to initiate pulling the flux over, and then that's going to be connected up, and that's going to be then used to drive the other subscriber operations, which themselves can conditionally run in one or more threads. So this model is very much like what we had before, where we had a publisher, except before the publisher was coming locally, whereas now the publisher contents are coming remotely from the microservice. And then the final operation here is just stop publishing. We go ahead and send a delete request telling it to stop publishing. We get back the result, which is just a void mono, and we block until we're done. So notice that stop publishing is a blocking operation, and the create is a blocking operation. But this operation here, the start publishing one, is not a blocking operation, and we get back a flux of integers. So armed with that knowledge, now let's go back and see how this code is actually used in the program. So we set ourselves up with the hybrid back pressure subscriber. We initialize our composite disposables as before. The main program looks identical. We go ahead and create a memoizer initially, and we test that first. And then we go ahead and create a version that doesn't have a memoizer, just uses the isPrime method directly. We test that next. That's all identical to before. And now let's go ahead and take a look at the run test method. This is the part that's now different because we're getting the data from the publisher microservice. So we come in here, and the first thing we do is we say, hey microservice, please start publishing. And so what that does, and this is really cool, what that does is it's going to give us back a flux to an integer whose stream of integer values, random integer values, will be coming from the remote service, so the microservice. So this is actually coming at us, and we just kind of started the wheels in motion. But once we do this initial call, we don't have to keep sitting there and saying, get me the next one, get me the next one, get me the next one. Instead, it's all going to be coming to us depending on how we're going to set up the back pressure model. From here on out, however, this looks pretty much identical to the code we had before, except the publisher is now running in a different process as a microservice. But everything else looks the same. We're going to define a function that will take each random number and then go ahead and publish it on the subscriber scheduler, so which may have one or more threads in it. And then we're going to go ahead and check to see if the number is prime. And so that's identical to what we had before. Again, as before, we're either going to turn logging on or off, and then we're going to go ahead and use the flat map idiom in conjunction with publish on and be able to determine the primality of all those streams of random integers coming from the flux that's emanating from the microservice. And the subscriber goes ahead and starts all the wheels in motion. We're off to the races. We sit there and wait for everything to finish. And then after we're done, we go ahead and we tell the publisher proxy, hey, stop publishing, please, because we're done with this particular test run. And so that will then go ahead and tell it to stop publishing. Okay, and that'll then shut down the way that works is that shuts down the scheduler that's running in the other address space. Okay, so that's basically it. So let's go ahead and run this. I think if you recall, I'd already started running the publisher application earlier. So that's off running in the background. And if you come over here and look at run, you can see that it's up and running. So now let's switch over here and let's go ahead and run the EX4 main program. This is essentially the subscriber. And we're going to do a couple of interesting things. I'm going to keep it a very small count to begin with so we can see what's going on. And you can see initially we've got debugging turned on. We're running in parallel. We have one thread for the subscriber that's different from the publisher thread that's running the publisher proxy. We're going to have 20 items. We have back pressure turned off. And then we're also going to print out a couple of things. These are just debugging tags, so we're going to dump the output. So let's go ahead and run that little program. And you can see we're going to run it. So this should go ahead and start up. And the first thing it'll do, of course, is it'll connect to the publisher microservice. It'll tell it, hey, here's the count of the number of values I want. So you can see it's starting with count 20. And now it's basically waiting in the main thread for the results to occur. If you take a look at this, there's basically 20 of them because I asked for 20. There's no back pressure enabled here, just sending them to us and we're just processing them. And there's a one prime detected. There were 8 duplicates. And then we run it again with the memoization turned off. And you can see here that the times are about the same. So we had 1 prime and a bunch of elements. So now let's go ahead and change the configuration a little bit. Let's try running, I don't know, 50 elements. Except now what we're going to do is we're going to crank up the number of threads. So let's say we want to have 8 threads running simultaneously. And oh, you can see before that, so subscriber had a single thread and it was subscriber-2. So that's the one that was used for all the processing. Now we're going to crank this up again, except this time you can see that we have lots of different subscriber threads that are running. And so they're off to the races. I created 8 of them. So we have a whole bunch of subscribers. Again, it cranks through with both approaches. You can see again that the times are pretty close together. And the memoization isn't really buying us a whole lot. There could be a variety of reasons for that, but this particular approach really isn't focusing on the memoizer. It's really focusing on how we're going to do things with the publisher running in its own microservice. Let's now go over here and let's set the back pressure from false to true. And you'll notice before that the data was all just kind of blasted to us. Now we're going to do it with the hybrid model. And what it's going to do this time, hopefully, is it's going to request them in tranches. So if you take a look, you can see we get these tranches of data. So it basically gets, I think it looks like about 8 of them at a time. And we can control the tranche size if we wanted to. But you can see it gets it in tranches as opposed to having it all blasted there in one fell swoop. And again, the memoizer's kind of slowing us down. I think we'd probably have to have a lot more items here before the memoizer would really give us a big win. Let's see what happens if we crank it up to 100. A lot of threads running here at this point, so that's probably making a difference too. Let's see. So it's off cranking away on 100 items that are being generated by the microservice, and now you can see the memoizer starting to be a win. So the larger the number of items, the more likely we're going to have more duplicates, the better results we're going to get with memoization. Let's see how many duplicates we actually ended up having. We had 39 duplicates out of 61. So that means there's a bunch of things that didn't have to be recomputed. So that's basically what I wanted to show today. I think it's really cool how incredibly easy it is to convert from the standalone Flux or mono approach where everything is in one address space to the distributed or kind of client-server style model using WebFlux and keep the semantics very similar. I have not yet fully mastered the ability to debug stuff on the microservice side. I think there's probably some flag I need to set to get all the debugging information logged that I'd like to see. If anybody knows what that is, let me know and I'll turn it on. Because it would be fun to kind of log and see what's going on with the microservice side of the house. But you kind of get a feeling for how this all works, hopefully by looking at this example. And the key take-home point is just how simple it is to be able to do this kind of remote communication with fluxes as the means to bring things together. I don't have to write complicated iterators. I just basically say, here's a flux. Go to town and have a good time. So that's really cool. Okay, so with that, let me go ahead and stop and answer some questions. Let's see what we got here. Shouldn't the endpoints in the controller class be business API related? Not really sure what you mean by that. I was trying to find a way where I could test out the ability to configure the publisher with the right set of values so they could be shared between the test runs. I wanted the way to start publishing. I wanted the way to stop publishing. If that's not business application or business API related for the business of doing this test, I don't know what is. But if anybody has any suggestions about other ways to design this, I'm all ears. The main thing I wanted to be able to do was be able to have fine-grained control to make sure that all the test runs, in other words, the test run with the memoizer and the test run without the memoizer, all worked off of the same data. So that's why I designed it that way. But I'm always happy to learn new things. Shouldn't those endpoints be called internally as part of some business service invocation? Again, if anybody wants to suggest an alternative approach, that's great. I didn't see how else to do it, but I'm sure there's lots of things I can learn. How can we handle the cases where the server application is working off of many different monos and fluxes? Again, we'd have to look at specific use cases to decide what you need to do, but I can imagine a whole bunch of different ways of doing that. In this particular case, I just needed some way of being able to start some operation and get back a flux. So you can imagine anytime you need to do that, like imagine, for example, that you had a middle tier server that was both a client to a bunch of other microservices and then a server or microservice to one client. So it's a middle tier kind of thing. Maybe it's going out there, for example, for doing some kind of, travel reservation site back when people used to, travel. And in that case, you might go off and, find the lowest fares and find discounts and find getaway deals, find exchange rates. And all of those things might very well end up being calls to different web servers, microservices themselves probably. And they might all be giving you back fluxes to flows of things, like flows of flight costs or flows of deals or whatever. It's not flows, fluxes. And so all those things could come back, and you can imagine a situation where you'd want to be able to have your middle tier microservice get all that information back and then merge it together or zip it or whatever you need to do into one final result that it's going to give back to the ultimate client. So in that case, you probably would end up having different operations to the different microservices to ask them for the information that you needed. But again, it's really up to your application. I like application-driven examples because they're more interesting than just looking at the mechanisms by themselves. The approach is subscribing. The approach is exposing the implementation details to subscribers. Shouldn't all these be handled by some middleware like Reactive Netty? Yeah, again, there's lots of different ways to design this. So if somebody else wants to take a shot at taking this and redo it, go for it. That's fantastic. I was just trying to get an example that would demonstrate. The real point of all this was in response to a question I got the other day when I was presenting the mono-based version. I think maybe Tim asked me, hey, I'd like to see a Flux-based version of this. So this whole thing was driven by the desire to quickly put together a Flux-based version of the example. Now, the interesting question here is if the business API is create prime, well, create prime isn't really what we're doing. We're generating data. We're publishing the data. And so you could certainly have that API exposed at a higher level. But I also wanted to be able to show people how you can have fine-grained level controls of all the different pieces. So, how you package that up to other layers in your system is really a multi-layer architecture question. Something else that's also worth noting here is that you can imagine a scenario where we would have like a publisher microservice that would generate data We could have another microservice that would be the check if prime microservice, and then we could ultimately have that come back to the subscriber, which would then probably visualize this somehow. My particular subscriber here is kind of lame because all it's really doing is just printing the results on the console. But you can imagine this thing being hooked up in a more realistic application to an Android GUI or some kind of display on a browser or whatnot. So that would all be, those are all things left as exercises for the watcher, for the viewer, if you want to take this and explore it further. So I wanted to show you this particular example because I thought it was cool, demonstrating how easy it is to create fluxes. Something else I want to talk about, we won't go through this right now, but we will do this probably tomorrow. Let's go over to here. So I'm going to share my screen again real quick. So what we're probably going to do tomorrow is we're going to revisit the WebFlux folder example I looked at the other day. And let's see, let me get rid of the other project here. I have to shut everything down. So I've gone back, now that I'm a lot more knowledgeable about how WebFlux works and annotations work, I've gone back and greatly improved the example we talked about the other day, which is the one that creates a composite hierarchy of folders, subfolders, and documents. And I had to make some compromises in my original design because I wasn't as savvy about some of the magic annotation lore that you can use with Jackson in order to be able to take inheritance, objects that have inheritance relationships, and then be able to automatically stream them and then reconstruct them as objects respecting the inheritance on the receiver end. So I've now since learned that, and that's really cool. So tomorrow we're going to kind of explore how to process recursively constructed objects, which is really cool. I honestly never would have stumbled upon this incantation had not one of my colleagues known how to do it, but I'll show it to you tomorrow. And this will also give us a chance to show some other cool things like the following. It's actually possible to treat the results that come back as monos or fluxes as Java 8 plus mechanisms like completable futures or streams and so on. So I've got this really cool example where I can not only treat things as, let's see if I can find it. Where did it go? I think it's in, it's the test, here we go, run remote tests. So we'll look at this in more detail tomorrow, but basically I can get the results back using monos and fluxes because that's what WebFlux knows how to send. And then I can convert them into streams or completable futures. So if you prefer that mode of programming for whatever reason, then you can use WebFlux as a mechanism to work with streams or completable futures on your client and server, and then have them come back as monos or fluxes and then convert them back into streams or completable futures. Why you'd actually want to do that is somewhat of a mystery to me because the mono and flux stuff is pretty cool. But if for some reason you really like to use the Java streams and completable futures abstractions, they're easily accessible with simple adapters. So I thought that was kind of cool. So we'll have a chance to take a look at that tomorrow as well. I've also done some other improvements, just making the whole program work more effectively. So we'll probably explore that tomorrow. I really want to show you how we handle the recursive inheritance relationships with just one magic annotation in JSON. But I don't want to spoil the surprise, so we'll go ahead and cover that in tomorrow's session. Okay, let's see if there's any other questions. Some examples on how to hide the create stop calls from the user would be nice. Again, there's really nothing to it, right? You just have to define a layer of abstraction that encapsulates all those low-level details. Maybe I'll refactor one of the examples to make that more clear, but it's so mind-numbingly easy to just provide a little wrapper or a little facade around those things so you don't have to know that that's what's taking place under the hood. It's just a simple level of indirection. There's a great quote that once said, no problem in computer science is so complicated that it can't be solved with enough levels of indirection and or enough levels of abstraction. So I think that's probably a good time, good way to end today's session. Thanks to everybody for coming. I hope you found this useful. Please go ahead and like and subscribe if you like this, and I will look forward to talking to you again soon.